1, 2. We have volume expansivity. Volume expansivity is one of the kind of expansion of solids, which is a subtopic under heat energy. So in expansion of solids, we have three kind of expansion. We have the linear expansion, the area expansion, and the volume expansion. The linear expansion is also called linear expansivity. The area expansion is also called area expansivity, and the volume expansion is also called volume or cubic expansivity. So in the previous lesson, I have explained the linear expansivity as well as the area expansivity. Today we have the volume expansivity, which is defined as the fractional increase in material's volume per degree rise in temperature. And the temperature may be in either in Kelvin or in degrees Celsius. So that is the volume or cubic expansivity. It is a fractional increase in material's volume per degree rise in temperature. It represents the three-dimensional expansion of solids, liquid, or gas. Three-dimensional expansion of solid, liquid, or gas. For example, if this is a box, like this, if we have a box like this, so this dimension at the front, and the dimension at the top, and dimension at the side. So that is three dimension. Dimension at the front, dimension at the top, and dimension at the side. That is the three dimension of this box. So this is an example to show you the dimensions or three dimensions. And volume expansivity is a fractional increase in volume of solid, liquid, or gases per unit rise in temperature. It is denoted by this letter. It is denoted by this letter, which is this. And this volume expansivity is the same thing as B2 minus B1 all over B1, then theta 2 minus theta 1. So that is the formula for calculating volume expansivity. So this volume expansivity is the same thing as delta B, which is change in B, all over B1, then delta theta or T, delta theta, which is change in temperature. So this is also the same thing as delta B all over B1 delta T, because this theta and T, they all mean the same thing, which is temperature. It may be given as theta, it will also be given as T. So they mean temperature. So this delta means change in B, which is B2 minus B1, and this B1 is already there, and delta theta means theta 2 minus theta 1. So it came back to its original form, which is volume expansivity is equal to B2 minus B1 all over B1, theta 2 minus theta 1. Example, the increase in volume of 10 cm cube of mercury. The increase in volume of 10 cm cube of mercury when the temperature rises by 100 degrees Celsius is 0.182 cm cube. What is the cubic expansivity of the mercury? So that is the equation. So now the solution. So the cubic expansivity of the mercury is equal to, now I'm going to apply the formula, which is delta B all over B1 delta T, and this is equal to, that is change in volume is 0.182 0.182 182 cm cube all over the B1, which is volume number 1, is 10 cm cube, 10 cm cube, which is this, and delta T, which is change in temperature, is times the 100 degree Celsius. So now this volume expansivity is equal to 0.182 cm cube all over 10 times 100. We are going to have 1000. So, and this 0.182 divided by 1000 is the same thing as 0.0000182 per Kelvin, because per Kelvin is the unit of the cubic expansion or cubic expansivity, or the cubic or volume expansivity. So therefore, this volume expansivity is equal to, now it is in decimal form, I can convert it, or I can leave it this way in decimal form. I can also convert it to standard form, because decimal can be converted to standard and standard can be converted to decimal. So now, converting this decimal to standard, we have 1.82 times 10 to the power of, now 1, 2, 3, 4. So minus 4 per Kelvin. Minus 4 per Kelvin. So that is cubic expansivity is equal to 1.82 times 10 to the power of minus 4 per Kelvin. So that is the cubic expansivity of the mercury. So now the cubic expansivity of the mercury is 1.82 times 10 to the power of minus 4 per Kelvin. So that is the expansion of the mercury, the cubic expansion of the mercury. That is the cubic expansivity of the mercury. Cubic expansivity of the mercury. 1.82 times 10 to the power of minus 4. So I'm going to stop at this point. We'll continue in the next one. Have a nice day.